Hey everyone, and welcome to the What's New video for Phoenix 5.10 and 5.20, which we released just a few days ago.
If you don't know us, I am Georgi, product manager for Phoenix, and this is Svetlin, who is our dev team lead for the project.
Indeed.
In this video, we're going to cover everything new and improved in the changelog, and we're going to show you how you can use the new features and what you should be excited about.
Yeah. All right, so we're covering both versions because we didn't do such video when we released Phoenix 5.10. So we combined many of the new features and the improvements in one list. And the good thing is that we actually improved many of the things that were new in Phoenix 5.10 in the version 5.20. So now we're going to present them to you all together. So first off, we added official support for Max 24 and Maya 2024, which has been waiting for a while. We had that support in the nightlies for a few months already. But if you're waiting for the official release in order to get the official Max and Maya, here they are. So here is Maya 2024 and here is Max 2024. You can understand that this is this version because it says Olympus right here. All right, so we're going to be demonstrating all of the following stuff inside of Max 2024 and Maya 2024, so you would believe that they are really working. Also, we dropped support for Maya 2019, so V-Ray for Maya also dropped this version, so we no longer support that. One new other addition that we added in Phoenix 5.10 was that now if you install a mismatching version of V-Ray and Phoenix, there is a message when you start rendering inside of Phoenix for Max and Phoenix for Maya. So it's very important that when you go here to download.chaos.com, when you install a Phoenix build, you should be aware of the V-Ray version that you have. So if you have V-Ray 6, you should install Chaos Phoenix for V-Ray 6. If you have V-Ray 4, you should install Phoenix for V-Ray 4 or for V-Ray 5. And if you're using any other renderer, it doesn't matter which one you install. So this one matters only if you have a specific V-Ray version. The problem is that if you have V-Ray 6 and install Phoenix for V-Ray 5, there are going to be unpleasant things happening, and there is going to be an error dialog showing you that something is wrong so that you will be able to update your install.
Yeah, in this case, where it says V-Ray 6 and other, this means that if you use Corona, for example, you can get the build where it says and other. So in this case, both builds will be working with Corona, so it doesn't matter which one you choose.
Yes. Oh, it actually logged me out. So yeah, I was going to show another version where we also have V-Ray Next support. Was it 2022 the last version where we had V-Ray Next? I don't remember. Yeah. Anyway, yeah, it's important that you install the build that matches the V-Ray version. If you miss to do that, now there's going to be a message telling you that so that you don't get in trouble and wonder what's actually happening. And another change that is, again, in the same ballpark is that if your installation doesn't go right, and for some reason, one of these two environment variables, so this one is for Max and this one is for Maya, if those environment variables cannot be read by Phoenix for some reason, there's going to be an error when you start the simulation. And it's going to tell you that something's wrong with your install and you should install again. This might happen if you're doing a custom install. So there is a way to run Phoenix from an arbitrary location, so without running through the installer, for example. So this is one way for some of these environment variables to go wrong. We have, if you want to run Phoenix from an arbitrary location, you can do that, and we have this. We have it described in the docs. I can even show you where it is.
Yes, it's working for 3D Studio Max and for Maya as well. The workflow for Maya is a bit cleaner because this is a proper thing in the Maya environment. While in Max, it works only for the new Maxes. You need 3D Studio Max 2022 and newer. So in case you have a brand new Max installation, you can run Max from a custom location for the network, for example, and this would be easier to update if you have many machines that are using the same installation files.
Yep, that's right. So yeah, whenever you have a more complicated setup, you can set up Phoenix this way as well. All right, so this was all for the supported versions and kind of the infrastructure part of the presentation. So next, we're moving on to many user interface changes. So you can see that the first block of these changes only concerns 3ds Max, at least for now. So in Phoenix 5.10, I ported many of the simulator rollouts to Qt. So this means that selecting the simulator is going to be faster now. So I'm going to create a preset, and when I open the simulation, the simulator options, opening those was very slow in previous versions. So this started happening around Max 2019 when 3ds Max started getting ported to Qt. So selection of the simulator started getting slower and slower. So now that we ported those rollouts to Qt, now selecting the simulator is fast again. And in version 5.10, I managed to port only some of the simulator rollouts. Then in version 5.20, I managed to port the rest of them. So now there is also the simulation, the rendering, the preview, scene interaction, and input rollouts are all ported to Qt. So the entire simulator and the V-Ray volume grid are now ported to Qt. So now they show faster when selected. And this comes with some additional perks. So first off, each of the rollouts now has this expand button where you can make it floating, and then you could dock it somewhere inside of the 3ds Max user interface like this, or like that, or you can even create tabs. But when you do that, and when you close 3ds Max, this layout gets lost. So what we did in addition to that was to create a new Phoenix main floating window. So now basically we have floating user interface inside of 3ds Max. You can open this from here, from the Phoenix menu, like this, or you can open it from the simulation rollout of each simulator, like this. So this way, you could dock the different rollouts of the simulator inside of this Phoenix main window, like this. And again, you can create various different layouts. You can create tabs like this, or you can dock them side by side. You can resize this, and you can place it anywhere you want on different monitor. And this layout gets saved to the Max file. So the next time that you open the scene, the layout that you've ordered is going to open and is going to remain the same throughout your setup. So
next cool thing that we need to show, I think it's the pin functionality. So if you notice, if Svetlin selects a rollout, you'll notice that at the top left corner, there is a pin button that is glowing in blue. This means that even if you deselect the simulator, the rollout will still be alive, and you can have all the rollouts live without the simulator selected at all. If you disable the pin and deselect the simulator, they will be gone. And in case if you don't like this functionality, what you can do is you can go under the Phoenix preferences menu, and there we have an option to enable the pinning by default. So now it is disabled, and you can select the simulator and the rollout will show. But yeah, in our case, we like the pins by default.
Yeah, they're on by default. So, and this thing is also present here in the volumetric options that Phoenix had for a long time. So you have seen these controls for many years. And now they also have the pin icon. So again, if you deselect the simulator, they are going to remain here. But the previous behavior was that when you have that window open, if you deselect the simulator, they are going to disappear. Selecting it again will make these that floating window appear again. So yeah, we have this for the volumetric settings as well.
Yeah, if you have many simulators in the scene or many volume grids, having all of these open is a lot more flexible and useful, at least for us. So this way, you don't have to wonder which simulator have you selected already.
Yep, and also the main Phoenix window, it also accepts different rollouts from different simulators, and you can see that right here we have the dynamics rollout of the fire simulator, and then the dynamics rollout of the liquid simulator. And yeah, eventually, I'm hoping that we would be able to port all of the user interface for the sources and the particle shader to Qt, so that you'd be able to dock that inside of the Phoenix main window as well. So we're going to have a full-blown floating user interface for Phoenix that many of you have been waiting for a long time to get. So I guess that's pretty much it. Yeah, we're trying to say everything that we know about everything and warn you about any limitations or anything specific that you need to know about these new things. So here is the pin button of the volumetric road. Yep, it also applies for the voxel shader node. If you've forgotten about this, here under Phoenix FD we have the voxel shader as well. So it's like the particle shader. You need to connect it to something that loads the data, for example, a simulator or in our case, a simulator. And it also has all the rendering options. So here is the volumetric window again. Next, what do we have here? Floating user interface, Phoenix main window. Yep.
Yes, we just showed that.
Yes. The layout is saved, is preserved. Yep. Implemented the user interface of the ocean and foam textures in Qt. Yep, we did that. So it's right here in the material editor. So when you create a Phoenix ocean texture, that user interface is now in Qt as well. And what else? The foam texture. Here it is. So both of these are now Qtified. The other two Phoenix textures, the particle texture and the grid texture, are still using the old user interface. So selecting them is going to show the user interface here maybe a bit slower. So yeah, the idea is speed. And yeah, so eventually we're going to port these to Qt.
And everything will be super fast.
Yeah. And what else? Also, some improvements to the preview rollout. So first off, in Max, let me close all of these. So do we have a preview rollout here? Nope. I'm going to find one in the simulator. So yeah, here it is. Going to close the Phoenix main window. So you can see that the preview rollout is pretty big. It's quite huge. And we did several changes to it, so I'm going to just combine all of this into one. So first off is that we reordered it, and now the on and off switches for all of the important preview types are near the top of the preview rollout, so that they could be easily accessible with less scrolling and stuff. Let me make it even. Whoa, so this is an enormous rollout. Yeah, here it is. Okay, so yeah. The show mesh checkbox is here, the GPU preview on and off switches here, and when you turn it off, it just hides all the settings that are not relevant at the moment, so they don't take up space. Same goes for the particle preview. If you turn it off, it hides all of the related options, and same goes for each of these grid channels here. And another thing is that only in 3ds Max, I swapped these two minimum and maximum ranges for each of the grid channels. So in Maya, this was the minimum, this was the maximum, and now it's the same in 3ds Max. Otherwise, they were the opposite way around. And this reorganization of the preview rollout also applies to Maya. So unlike most of the stuff that I mentioned so far, we have this. Let me just close all the other rollouts, show you the preview rollout. Here it is in Maya. So yeah, we have the mesh and the GPU preview. The particle preview still remains. And yeah, this is going to also come fully to Maya soon. It's already done in the nightlist, so they are exactly the same there. Yep.
Yes, we just covered this.
Disabling mesh preview, streamlines. Yeah, when you let me show you this. So currently the force preview, if you enable it, here you get the you get the list box for choosing the forces that are going to be shown in the force preview. When you turn it off, it disappears. So yeah, it takes less space, and hopefully it's more compact this way. All right. So next, again, concerning the user interface, we have a new simulation speed rollout. So it looks like this. Here it is. It's under the simulation. So there is simulation speed right here. So let me just clean up the scene. Let me just create a brand new simulator. So if I create a fire smoke simulation like this, start the simulation, and here you can see how the simulation speed rollout looks. So it shows you the in order of most time taken for the simulation. It shows you the different simulation stages, and for each stage, when you select it or when you hover it, you get some tips showing how to actually improve this simulation stage. So this is kind of a helper for the more advanced users. And yeah, it would really help you identify if there is something unnecessary slow in your simulation that you can easily take care of. And yeah, it also shows different tips regarding how to save your caches. So for example, saving caches and loading caches from SSDs is much better than doing the same thing from the network or from Google Drive, God forbid. So there are many different tips for speeding up the simulation. So you can see that in this simulation, this is the first 2-bar preset. This is the fire preset. So the fluidity is the slowest part of the simulation. This is expected. Usually it takes 10 or 20% or even more. So this is kind of normal that this is the longest, the stage that takes the longest time. So we have some other stages here that might be susceptible to speeding up. So for example, exporting the cache and the viewport preview are taking 27% of the simulation. So if I go to the output rollout and turn on cacherless simulation, it should become better. And if I go to the preview rollout and turn off the GPU preview, you can see that
now our voxel preview is also slowing it down.
The voxel preview is also taking up some time. So yeah, we can dial this down to like 7, 8, 9% from the 20 something percent. It was about 25, 27% in the beginning. So yeah, for example, this works. And I guess this is the most important thing. So yeah, if you're using any forces in the scene that are interacting with the simulator and you've forgotten about them, they're going to show up here. And yeah, if you have many
geometry objects inside of your scene, this will show up in the scene. This will slow down the scene interaction, and it will take a huge portion of your simulation time. And probably you don't need this many objects to be interacting with your simulation. So this way you can see that if the scene interaction is taking considerable part of the simulation time, then probably you can optimize it by removing some of the interacting objects, either by going to the scene interaction route and excluding the object, or just by hiding the objects in your scene.
Yep. And yeah, so for example, if you've forgotten some options, so in liquid simulations, maybe you have viscosity, which is slower to simulate, or surface tension, or for example, you have foam and you have foam volume, the foam volume option enabled, and you've forgotten about this. This would show up here, and if you didn't do this on purpose, checking this rollout might remind you of some things that could help you speed up the simulation a little or a lot, depending on how things go. And there is also one important thing that is important for every simulation, that the steps per frame are a very important option. So, for example, a simulation that has 6 steps per frame is likely to be 6 times slower than a simulation with 1 step per frame. So yeah, always go for the least amount of steps per frame as long as it looks good. You need more steps per frame only if the liquid is moving, or the fire or smoke. If the fluid in general is moving very fast, then you need more steps per frame. Or if you have any obstacles or emitters inside of the simulator that are moving very fast as well, then you need more steps per frame. But if you don't, always go for the lowest setting possible, and this is going to help you have a quick simulation. So yeah, that's the simulation speed rollout. Am I forgetting something? I think that these are the most important things.
Yeah, this is the most important ones.
Yeah, and once we implemented that, it really helped us see some things that didn't really make sense, and some things that we could change in the code in order to make Phoenix generally better. So the simulation speed rollout is new in Phoenix 5.20, but before that, in Phoenix 5.10, we did mostly rendering optimization. Then in Phoenix 5.20, most of the optimizations were concerning the simulation or the viewport preview. So in 5.10, there were like 3 different major optimization to rendering. So if you had the fully visible fire mode, you can find it here. Let me find it as well. So here it is. So if you used fully visible fire opacity mode, also this is the default fire opacity,
or the volume white cache was enabled,
or the Phoenix volume white cache was enabled. So it is right here. Both of these are default options, unless you're using some toolbar preset which sets something different, or unless you're using some saved scene that you kept from before or downloaded from somewhere. So here's the volume white cache. So if you had any of these 2 options, rendering of your volumes should be up to 25% faster once you get Phoenix 5.10. And also, if you had the grid RGB channel involved in the rendering of all metrics in some way or another. So, for example, you could use the grid RGB channel for the smoke color, for example. Rendering such smoke, or rendering such volumes in general, is going to be faster in Phoenix 5.10. Then in Phoenix 5.20, more stuff came. So here is an improvement only for 3ds Max, is that when the Phoenix particle texture uses a particle system for something and gets rendered with motion blur, now this is much faster.
Yes,
so,
the speed is
many times faster,
massively improved. So in this case, for example, if you have a surface that is wet and you want to use the Phoenix particle texture to read the wet map particles in order to blend between wet and dry surface, and you have the motion blur enabled, this will be many times faster. So
yep. So this is one optimization. This only concerns 3ds Max. It was already fast in Maya.
Yeah.
So for the Maya guys, don't worry. So this was already working fine. So also the liquid simulations in general are could be about 15% faster now. It depends on the simulation, so it might be 0%. But yeah, for some scenes we got 15% speed up. Whenever you use wet map simulation, it could be even twice faster. So one example of wet map simulation could be the ocean preset. So for example, like this, if I just reduce the grid resolution in order to make it run faster. So these are the wet map particles, the particles where the liquid touches any geometry. So yeah, these red particles, they are the wet map. So if I splash the sphere like this inside the liquid, so you could see that here we have more wet map particles sticking to it. So simulations involving any form of wet map now are also much faster than before. Also, simulations that are writing VDB caches, or in general writing VDB caches from Phoenix. So, for example, if you are converting Aura caches to VDBs using the cache converter, so now this is 30% faster. By default, Phoenix writes Aura cache files. Let me go to the output. And yep, here they are, the Aura caches. But you can change the simulation right here to, for example, like that, to also write VDB caches. And now this kind of simulations are also going to be faster than before. What else? Simulations that use the grid velocity channel in the output row. So basically simulations outputting grid velocity like this. So this basically applies to all of the toolbar presets. So all of them are outputting grid velocity. So then you'd be able to render with motion blur. And in order not to have you finish your simulation and then remember that you needed to enable this when you started rendering and figuring out that you need another simulation. So this is enabled by default for all the toolbar presets. All of these simulations are now also faster, up to 5%, so not that much, but this speed up also applies even if cache simulation is enabled. So all of these are new speed ups in Phoenix 5.20. Then in Phoenix 5.10, only in 3ds Max, I did a lot of changes to the way emitting from particles works. So for example, let me reset the scene. I'm going to create a particle system like particle flow, just scroll it a bit so it creates more particles, and then I'm going to create our favorite fire setup. So if I start the simulation right now, something happens. Yep, you can see that it's working. I could even allow a bit more extra margin for the adaptive grid like this. So this kind of setup is now a lot faster, and you could emit from tens or hundreds of thousands of particles. And now it's going to be much faster than before. It's now multi-threaded. This kind of process wasn't multi-threaded before. Unfortunately, it also depends on the kind of particle system that you have. So for example, particle flow, reading the data from particle flow is going to be single-threaded because this is the best that particle flow can do.
Yeah, but in case you use TypeFlow, for example, TypeFlow is multi-threaded, and simulations using particles from TypeFlow would be really, really fast compared to the previous version.
Yeah, and if you want to go crazy, you could also, for example, simulate the particles with Phoenix. So in a fire smoke simulation, you could create drag particles, or in liquid simulations, you could use the liquid particles, the splashes, the foam, and you could use those as an emitter for another simulation. So if you have a second simulator, you could plug those Phoenix particles into a source. This is going to be multi-threaded, and yeah, it's going to be terribly fast in the new version as well. And also the memory usage is reduced. This change mostly applies to 3ds Max, but the memory usage is also going to be reduced for Maya as well. However, for Maya, emitting from Maya particles and M particles still needs to be optimized. So I need to also pay attention to that. And this was one improvement that I did in Phoenix 5.10. In Phoenix 5.20, again, mostly for 3ds Max, I managed to speed it up even more, reduce the memory usage even more, and now some scenes are about 5 times faster in Phoenix 5.20 compared to 5.10, and 25 times faster compared to Phoenix 5.01, which was the previous version.
So blazing fast. If you still using the old version of Phoenix, make sure to update to the latest one, as it's a lot faster.
Yep. Also, this one is only for Maya. So if you were getting tired of the things that are consuming code in 3ds Max, now in Maya, the particle preview is much faster than before. And this means that, simulations in Maya that are showing particle preview in the viewport, they are now much faster than before. So this is a Maya only optimization. And in some of our scenes, we measured up to 10% speed up of the entire simulation. So that is significant. Also sped up the particle preview of Aura caches from moving simulators that had the particle previews auto-scale cover enabled. So this is a special situation. It also had some other changes. I think that they went originally in Phoenix 5.10. Let me just double check, or maybe, I rather think that these changes were in 5.20. So when you have a moving simulation, for example, like an ocean sim, let me just, again, reduce the grid resolution, and I'm going to animate the simulator to move like this. For example, so in this setup, I'm going to have an ocean simulation. I'm going to have a moving simulator like this. Actually, should I have parented the simulator to the sphere or not? Let me just see if this one makes for a good preview of what I'm trying to explain. I'm going to turn off auto reduction, turn off the particle preview, reduce the detail reduction, and show the velocity preview. I'm going to hide or display the scene as the sphere as a box. So let me see how this goes. Okay, so you can see that since this sphere is actually moving in relation to the simulator, there are velocities inside of it. But now that we have a moving simulator, we can see these velocities only inside of the sphere. Otherwise, before Phoenix 5.20, whenever you had a moving simulator like this, the velocities were going to be shown in the entire preview because the entire simulator was moving, but this was not giving you any useful information because you should only be able to see the interesting velocities inside the simulation. You don't want to see an entire box filled with velocities because what does this mean actually? And so this works for the voxel velocities, and it also works for the particle velocity. So let me turn off a couple of systems. So I'm going to leave only the, maybe I'll turn off the foam as well. So here are only the splash particles. Here they are. I'm not really sure that we're seeing much interesting.
Yeah, I think that you need to parent the
sphere to the simulator. Or the simulator to the sphere. Okay, let me see what.
Probably go, to the first frame. And then parent it. Okay.
Yeah, let's see what happens. All right, so here are some splashes. They're starting to get created. I'm also maybe going to disable the phone simulation because I remember that.
Yes, now it's much better.
Mm-hmm. Yeah.
Yes.
And you can see that right here, the particle preview is also scaled according to the velocities, thanks to the auto scale color option right here. So the faster splash particles are white, and the slower ones are using this color that you specified right here. So, for example, I can make it pink. And in order to also make those particles better visible, now in Phoenix 5.20, I think, we added the option to 3ds Max to also change the particle size in the viewport. So, for example, I can make the particles larger like this if they appear too small.
Actually, pink looks really nice for the splash preview. I really like it. So maybe we should think about changing this to pink.
Changing the defaults, yeah. All right, so that's pretty much it. So now this kind of particle preview that I'm showing right now was really, really slow. So now it's faster. Yeah, this is the original thing that I wanted to show you. So sped up the particle preview of Aura caches. Yeah, also this one didn't apply to VDB caches. Didn't it apply to VDB caches? Since I wrote, we gotta check it. I wrote Aura caches, but these caches coming from moving simulators when the auto-scale cover, this one, was enabled. Otherwise, if auto-scale is off, you could change you could manually change the scale here. So you could get more of the bright particles or less of the bright particles. But yeah, when auto-scale cover was on, it was very slow to compute the actual scale. So now this is faster. 3ds Max only sped up the simulation of the paints preset by enabling render time only of the grid texture. So let me reset the scene again. Let me clean up everything. I'm also going to show you one kind of a Easter egg of Phoenix. So,
hidden feature.
Yeah, all the 2-bar presets can be created over a combination of several geometries. So you usually you could create a 2-bar preset whenever you had one geometry selected. But if you select many, the preset is going to be created over all of those geometries. And some 2-bar presets, like the paints preset, are doing some special things if you do it like this. So for example, the paints preset is creating different colors for each different emitter. And I think that, yeah, this also applies to some other presets, but I'm going to let you discover which ones were they. Not because I forgot which ones were they, but in fact, because I did. So one of them was the explosion preset. So it created different smoke color. So yeah, when you have many emitters, it created like gray and brownish and like dark gray and white brown, so that it would look like you have different materials exploding in the same explosion. And yeah, I think that
the ink in water, is the other one. Yeah, that creates different variations. But back to our setup that Svetlin is showing here. So what happens in it is we have different simulators with different Phoenix sources that are creating liquid with different RGB values. You can see that the RGB for each emitter is different. So this RGB channel is read by our grid texture, and by doing that, we can apply this grid texture to a V-Ray material and oops. Yeah. And if we render those out, we will get different colors. But whoa, it's way too bright. Yeah, we need to lower down the light. But when we're using the grid RGB channel to read this data, this slows down the simulation. So in order to minimize this, we have this render time only checkbox inside of the grid texture, which will evaluate the grid texture only during the render time. And when you simulate, this will be discarded and your simulation would be a lot faster.
Yeah, otherwise it gets calculated while the viewport updates, and you really don't want that because the result of that goes nowhere. So yeah. And again, this is one of those things that is 3ds Max only, but in Maya, it was fast. So it has always been fast, and this is something that can be slow theoretically even in 3ds Max. So in Maya, this cannot slow the simulation because it's happening differently in Maya. So yeah, now the paints preset is quite a bit faster as well. And finally, on the simulation performance and speed up front, so there is this new little option right somewhere.
Let's make a new scene.
Let's make a new scene. Making scenes is great. Oh, this has expanded quite a lot. So let me create a var scale simulation, and right here there is this new option which is called use GPU to aid simulation. So we named it quite broadly. So what it currently does is that it affects one simulation algorithm. It's the PCG fluidity method right here. So whenever you have the PCG fluidity, enabling this makes it run on the GPU. So you can see right here that the GPU starts getting loaded when this option is enabled. So This basically allows one phase of the simulation, the fluidity. Again, if we refer to the simulation speed rollout, that's this stage right here, which is the slowest stage of the Varsno preset anyway. So it moves that algorithm from the CPU to the GPU. And you can see the GPU is not fully loaded because only this piece of the simulation runs on the GPU. Then it goes back to the CPU. So currently in Phoenix 5.20, this helps only fire smoke simulations, which have the PCG fluidity enabled. But in the future, we're going to port more and more of the simulation methods. So eventually it's going to also help the liquid simulations and so on. But now if you have a good GPU, it won't help you only for the GPU preview in the viewport. It can also help you for the simulation. So from the tests we run, of course, the results are different depending on what is your CPU and what is your GPU. But the best we could get on a few of the office machines that we tested was about 25% speed up of the simulation in general. So the entire simulation is running 25% faster, which is okay, I guess. So
a cool thing is that this thing works on both AMD video cards or NVIDIA video cards, and as well it works on Linux. We still have to add support for Mac GPUs.
Doesn't work on Mac.
Yeah, but using it on Windows and on Linux is a great method to speed up your simulations.
Yep, and we're going to continue working on this. So it's helping the simulations a lot in some cases. So that's pretty much it from me for this section, and we can switch places. So yes. Georgi can show you the rest of the interesting stuff.
Okay, guys. So we have changed, and let's dig in on to the next things. So we did a lot of improvements on the preview, and in Phoenix 5.10, we have implemented the force streamline preview to work how forces would affect the simulation even without loaded caches. So if I use this simulation that Svetlin made in here, let me maximize my viewport preview, and let's go and disable the GPU preview for now, and I will disable the smoke voxel preview because it will get in the way, and let's enable the force streamlines. And as you can see, now nothing happens because we have no force that affects our simulation. So I will go in here and let's create a turbulence. Then we can go in our simulation here and go through the forces and pick our turbulence node. And if we scroll down or scrub our timeline, you can see that we can see the force even on the frames where there are no caches and there is no simulation. And what's cool about that is now we can see how the force will affect our simulation even before we run it. So if I go in here and change the size of our turbulence, we can see how this affects our grid. Actually, I will go and make the grid a bit larger.
And also, let's turn off the auto reduction.
Yes.
Let's fix it to a certain. Oh, it's pretty high right now.
Yeah, it's pretty high right now. So let's.
Yeah.
Oops.
Maybe we could set it to something like 3 or 4. Or something.
Let's try 4, for example. And yeah, it's pretty detailed. So let's try 5, 6.
Mm-hmm. Yeah.
Even 7. Okay. So now, if I go in here and change the size of our turbulence, we could get an accurate preview how this will affect our simulation. And if I scrub the timeline, we can see the speed of our turbulence. So if I want it to be slower, I can do a rate of change of 0.1, and this will make the turbulence move slower, like this.
Yeah, so it's barely changing in time now. It's mostly staying in place.
In case if we want to make it faster, we can change the speed to 3, and we can see how this affects our simulation. So what's new in Phoenix 5.10 is a button for converting the Streamline preview into native 3ds Max splines. So if I want to visualize how this Streamline preview looks as a spline, let me actually make it a bit larger like this, and maybe also I will increase my detail reduction so that I get something funky like this. Now what I can do is go in here in my preview rollout, and in here down we have the auto bake option. So now if I turn it on, and you can see that we have some splines created over our Streamline preview, and in here it created a node right under our simulator. And if I scrub my timeline, you can see that these splines are animated. And if we want to reduce the thickness, for example, we can do something like 0.1, and we can make them thinner. And these are now regular 3ds Max splines, so I can hide my simulator. Oops, so if I hide it, it will disable our simulator, but I can make my simulator non-renderable. And now if I create a dome light and we do a quick render, we can see our smoke shows up.
Mm-hmm. Yeah, do they have a material already?
But didn't
I make the simulator not renderable?
Or I made...
Or was it the splines?
Or maybe I made...
Maybe it was the splines, yeah.
Yes, I made the splines not renderable. So let
bring
me
them
do
back
it again. Okay.
Yeah,
We wanted the exact opposite thing. And yes, we have the splines shown up in here, and we can go in here, apply material to them, and make them, for example, black, and make them reflective. And did I apply the material? Not sure, but let's make this dome light invisible. And we have these nice splines that are also animated. So you could create really, really funky effects. And actually a really nice effect that you can achieve is by making them self-illuminated like this, and they will start glowing. And then what you can do is go in here, create lens effects correction, and make this a bit higher, and they will start glowing. Okay. So.
And also, yeah, there is also the button for saving one single frame of splines in case you're happy with just a single frame. If you don't want the animation, you can just click the button. It would create the splines for you, and then you can again do anything that you want with them. And this also applies to Maya. So in Max, you are creating splines. In Maya, you're creating Maya curves.
Yes. So maybe let me show it quickly how you can do it in Maya, because in Maya it's a bit different, but the same principles apply. So I can make a simulator, I can create a turbulence force, and then let's shift click my simulator so that both are selected. Then we can go under the preview. Let's close the particle preview. Go under the force streamlines and add selected forces or fields, and this will create our turbulence in here. So if I scrub my timeline, we can see that we have it animated. And if we change the settings for our turbulence, like the size, for example, we have the velocities. Maybe
you can increase the length of
the length. So streamline length, and probably play around with the detail reduction in here. Like so.
Yeah.
And in case we want to create splines from these guys, we can go in here and bake the streamlines to curves. And if we go in here, we'll see that we have these curves. And if we want to render them out, we can select this streamlines node, go to V-Ray, and in here we have the V-Ray renderable curve attribute. So we can apply this to our selection, and in here we can specify a certain V-Ray material. So we can go and apply a V-Ray material for these, and let's create a light because we need one. And yes, let's do a quick render, and we have our splines.
Oh yeah.
And of course, you can tweak these through the renderable curve, and you can make them taper over the end. So actually, let's do it like 0.1 and 0.02, for example. And if we do a render, we get this nice effect.
Yeah, so yeah, now they're looking like the velocity preview. Now they're actually arrows.
Yes. Okay, so what's next? We actually in 3ds Max we automatically enable the viewport visibility and render visibility for the auto-generated previous splines like we saw. So you can just hit render and they will work.
Yeah, the four streamlines were new in 5.10, and baking of streamlines to splines was new in 5.10, and then in 5.20 we made the auto-generated splines automatically renderable and visible. So in 3ds Max only.
So next thing that we improved is the slice preview, and we implemented with option. So if I go back in 3ds Max in here, and if we go under the preview, we can go in here and enable, let me disable the streamlines baking because we don't need it anymore. And I will enable the slice preview. And if I go in here, we can see that only a slice of our streamlines are shown. But if I increase the width like so, and we can see that we get a thicker slice of our simulation, and we can evaluate how our force would be moving, and we can see how the turbulence produces these nice swirly effects. And of course, this is working not only for the force preview, but if I go in here and enable my smoke, and let's lower the detail reduction, we can see how our simulation looks like.
Yeah, we can also move the slice back and forth.
Yes.
And, control the width. And yeah, this is a way to actually kind of debug your simulations, get more information about what is actually going on inside of the fluid. And yeah, it works for the splines, it works for the voxel preview of the temperature and the smoke and the fuel, and it also works for particles.
Yes.
It doesn't work for the GPU preview.
Yes, it works only for the splines, for the particles, and for the voxel preview.
Yeah.
And what's left?
Option to change the particle preview sizes in Max. Yeah, we had this in Maya. We didn't have it in Max, but yeah, we showed it just a while back.
But just to show it really quickly, in case someone forgot about it, if we do tap water preset under in here for the preview, we have this particle size option. So if I increase it, we can see that our particles will become bigger. Probably this would be more visible when our liquid starts splashing. Yes.
Yeah, we could also reduce the detail reduction, for example, to in order to show less particles. And
we can increase the detail reduction. So let me disable the mesh preview, and we can see that increasing the particle size will make them these bigger cubes. It's actually not cubes. They're
billboarded
billboarded boxes. But now if you have a low-res simulation and you'd like a better preview of how it looks, you can bump up the particle size in 3ds Max, and you can get a better preview so that you can adjust your simulation to your liking.
Mm-hmm.
Okay, and what's next? We have made the background color of the extended GPU preview global for all simulators, and it's now accessible via right-click menu in the viewport. So what this does is, let's create a new scene actually, and let me do fire preset. And what we can do in here is go under in here and go under it's
extended viewports.
Yes, it's in the extended viewports, and we need to enable the Phoenix GPU preview. And if I select my perspective view, we get a GPU preview in this dedicated window. And now what I can do is right click over it, and we can change the color. So we can make it something like green. For some reason, it didn't update it, maybe because my simulation is running.
Yeah.
Okay.
Here it is.
Now updated it. And the cool thing is that if I go in here and make another copy, and it is shown in the extended GPU preview, now the background color option is global, so it affects both simulators.
Yeah. The problem was that previously this was an option that was a member of each simulator. So you could have one simulator with green background and another simulator with brown background, and changing between the simulations change the color of the the extended viewport with the GPU preview. And it didn't make sense. So now it's just one single background color for all of them. And also this is the GPU preview in 3ds Max that can save images.
Yes, what's really cool is that you can go under preview and where it is. Yes, let me expand this and let me hide this. So in here, under the GPU shaded preview, you have this option that's called saved GPU preview images. So in here, you can specify a frame range, and you can hit the save GPU preview button, and this will save your simulation inside of the folder where your caches are. And this way, if you have this option enabled, save images during the simulation, you automatically get GPU preview along with your simulation.
Yeah, you can get a really cheap preview of the simulation that you can check later without having to render it. And in 3ds Max it saves PNGs, I think. And in Maya you have more options. You can choose the output format actually. So we didn't have much requests about it, but if many people need it, we were going to implement the different file formats for Max as well.
And in case, just to mention, in case if you want your GPU preview images to be the same size that you're using for the rendering. Usually you want to do that. You need to enable these images in render size, and it will take the render resolution that you have in your common output size.
Yeah, this is pretty important because the viewport could be anything, so the aspect ratio could be anything, and you could end up with images that have odd number of pixels horizontally and vertically, and so some later when you're encoding those to video, for example, you will get unpleasant surprises. So yep.
And finally, we hit the diffuse lighting option for the GPU preview section.
It was right there, but now it's gone. So you could see that it's really gone now.
Yes, it was in here. Now it's on by default, and it's hidden. So
it didn't really make sense to have an option to turn this off because it didn't do anything useful. So I guess we're about the 1 hour mark, so we might wrap it up as the end of part one.
Yes, and we'll continue with all the other goodies in part 2. So stay tuned for the next one.
Yeah, we have more to come. Thank you for watching.
Yes, if you enjoyed this video, if you enjoyed this format, hit the like button. If you want to see more, subscribe to my channel. And we can't wait to see you in the next one. If you have ideas or what you want us to show you, just leave a comment below and let us know what's your favorite feature from this release. Thanks a lot, guys, and see you in the next video.
Thank you. Bye.